right, welcome back to another fun and exciting episode of 8th grade math. I'm your host, Coach Bartos, and today we are learning about approximation. So by the end of this lesson, you will know how to approximate the value of an irrational number and locate it on a number line. You will understand irrational numbers can be approximated by using rational numbers, and you will be able to explain these steps to simplify or approximate irrational numbers to place them on a number line. So before you started this presentation, I asked you a discussion question. I asked you to tell me what you thought approximation meant. So all I need you to understand about approximation or to approximate is just that it's close. It's not exact. So when we're approximating, we don't necessarily need a calculator. We don't need the exact answer. We just want to be close. So for example, if I were to approximate 2.9, I would say that 2.9 is close to 3. All right, so you've seen squares and square roots before. So let's do a little review. So a squared number is the product. So that word product means that we are multiplying. So a squared number is the product of a number and itself. So they are twins. They're the same number. For example, 2 squared is the same as saying 2 times 2. Well, we know 2 times 2 is 4, so 2 squared is 4. 3 squared would be the same as 3 times 3, which would be 9. So 3 squared would be 9. And 4 squared would be the same as 4 times 4, which we know is 16. So 4 squared equals 16. So when we're talking about the square root, it's basically the opposite. We're going the other way. We're going backwards. So a square root is one of the 2 equal factors of a number. It's one of the twins. So if I go back to our first example where we said 2 squared is the same as 2 times 2, which we know is 4. Now if I go the other way and I want the square root of 4, I know that it's 2 because 2 times 2 equals 4. If I wanted the square root of 9, well, I know that 3 times 3 equals 9. Therefore, the square root of 9 is 3. And so here's that example again. If I have 3 squared, that 3 is what we call our base number. That's the big number. That small 2, remember, is what we call our exponent. So 3 squared, the 3 is my base number, and that 2 is my exponent. So 3 squared we know is the same as 3 times 3, which gives us 9. And again, if I'm taking the square root, I'm basically just going backwards. So the square root of 9 would be 3. So here is that symbol for a square root. We call that a radical sign because look at it. It looks pretty radical. All right. So here are a couple visual representations of squaring numbers. So here I have a square. If I look at this square, I have 1, 2, 3 rows, and I also have 1, 2, 3 columns. So if I take my number of rows, which is 3, I multiply it by my number of columns, which is also 3, I get 9. So 3 times 3, or 3 squared, is 9. Same thing here. This time I have 1, 2, 3, 4, 5, 6 rows. I have 1, 2, 3, 4, 5, 6 columns. So I know that 6 times 6, or 6 squared, is 36. And if I go the other way, so now I wanted the square root of 36. If I know 6 times 6 is 36, then that tells me that the square root of 36 is 6. All right, so let's dive a little deeper into squares and square roots. So this says create a list of perfect squares from 1 to 25 along with these square roots. Because I love each and every one of you, I've already done this for you. Here you go. You can either take a picture of this with your phone and save it, or I uploaded it as a separate file to where you can go and download it under the materials tab. So if you look here, you see a bunch of numbers, okay? So just take a deep breath. All right, there's not a whole lot going on here. We have 2 main columns. We have our perfect squares, and then we have our square root of perfect squares. So right now, I'm just going to focus on this perfect squares column. So if I look on the far left, I have numbers going all the way from 1 down to 25. And if I look next to those numbers, I'm squaring each one of those numbers. So for example, 1 squared, or 1 times 1, equals 1. 2 squared, or 2 times 2, equals 4. 3 squared, or 3 times 3, equals 9, and so on, all the way down. So for example, here we have 18 squared, which would be the same as 18 times 18, which would give us 324. Okay, so on this first column, all I'm doing is squaring each one of those values. And if I look here on the right-hand column, so the square root of my perfect squares. So here's my perfect squares. Now I'm just taking the square root of each one of those values. So I'm basically working backwards. So if I start from the top, this time I've got the square root of 1. Well, I know that 1 times 1 gives me 1. So the square root of 1 is 1. The square root of 4. Well, 2 times 2 gives me 4. So the square root of 4 is 2. The square root of 9. Well, 3 times 3 gives me 9. Therefore, the square root of 9 would be 3. Okay, I'm just working backwards. Same thing here. Square root of 16 gives me 4. If I go down a little bit, the square root of 100. So 10 times 10, or 10 squared, gives me 100. Therefore, the square root of 100 would give me 10. Same thing down here. The square root of 361 would give me 19. Okay? So now let's use that to answer a question. So I'm going to exit out of here and bring up my perfect squares sheet. So this says when working with imperfect squares, you have to use approximation. You choose the 2 perfect squares that the imperfect square falls in between. Okay, so basically all that's saying is I'm going to pick the 2 values that this falls in between to help me approximate or find that value that this would be close to. So I want to approximate the square root of 24. If I look on my square root of perfect square sheet, I don't have the square root of 24 here. However, I do have 2 values that the square root of 24 would fall in between. If I look here, I've got the square root of 16 and I have the square root of 25. Well, I know that the square root of 24 has to be in between these 2 values, right? Because 24 is between 16 and 25. So the square root of 24 would be between the square root of 16 and the square root of 25. Well, I know that the square root of 16 is 4 and the square root of 25 is 5. Therefore, the square root of 24 must be between 4 and 5. Okay? Again, the square root of 24 would be between the square root of 16 and the square root of 25. And because the square root of 16 is 4 and the square root of 25 is 5, I know that the value of the square root of 24 must be between 4 and 5. And if I wanted to be a little more approximate, I could say that it would be closer to the value of 5 because 24 is closer to 25. Okay? So if I go back to the presentation, this is a review of what we just went over. So we know that the square root of 24 is in between the square root of 16 and the square root of 25. The square root of 16 is 4. The square root of 25 is 5. Therefore, the square root of 24 is in between 4 and 5, but closer to 5. Absolutely incredible. All right, so here's a couple more examples. So it says in your interactive notebook, we're actually going to do this right now. it says approximate the values of the square root of 38 and the square root of 13. So if I go back to my squaring and square roots cheat sheet, if I start with number 1, so I want to approximate the value of the square root of 38. Well, if I look here, I don't have the square root of 38. However, I've got 2 numbers that the square root of 38 would go in between. So I can see here I have the square root of 36 and the square root of 49. Well, I know 38 is in between 36 and 39. Therefore, or actually, let me back up a second. The square root of 36, I know is 6. The square root of 49, I know is 7. Therefore, if I know that the square root of 38 falls in between the square root of 36 and the square root of 49, I can approximate the value of the square root of 38 to be between 6 and 7. Okay. Now, which one is it closer to, 6 or 7? Well, I know that 38 is closer to 36 than it is to 49. Therefore, the square root of 38 would be closer to 6. Okay. The square root of 13. Again, let's find our 2 values that the square root of 13 would fall in between. Well, if I look here, I've got the square root of 9 and I've got the square root of 16. So the square root of 13 is going to fall somewhere in between the square root of 9 and the square root of 16. Well, I know the square root of 9 is 3. I know the square root of 16 is 4. Therefore, the square root of 13 must be between 3 and 4. And if I wanted to get a little closer, I could say that it would be slightly closer to 4. Okay. So I hope you guys thoroughly enjoyed this incredible lesson on approximation. If you guys have any questions over anything I just went over, please do not hesitate to call, email, or message me in Schoology. Okay? Until next time, guys, take it easy.